Hi, I'm an old guy and I do maths. Today we have a probability problem and we are looking for the mean and standard deviation of a discrete random variable x. Now, it has 5 values, 0, 1, 2, 3, and 4. And the probability of each is given by this. So, where do we start? Well, our first problem is that we have a pronumeral here. We need to find the value of k. And how we do that is actually fairly simple. Now, the backstory of this is that a pupil of mine got this problem and we were working through it. And I thought that it would be a good idea to run up some notes that I could let her have. And so what I'm doing in this video is I'm actually running through those notes. So there are some crossings out and it's a little bit untidy, but I hope you'll forgive that, and I'll just talk my way through it. So let's start with k. So how do we go about finding k? Well, it's actually reasonably simple. The function, if you will, that gives us the values of each discrete random variable must total to 1. So with every element of x, every possible element of x, 0, 1, 2, 3, 4, put into the equation, the total must come to 1 because all probabilities must add to 1. Right, well, with that in mind, we can work out quite a bit of this and then simply use a little bit of algebra to figure out what k is. So, if we concentrate here, x to the power of 4 is 0, 1 to the power of 4 is 1, and so forth and so on, and we get to 256. Now our instruction is to total these values. Now, when we do that, we get 354. And so we can rewrite this as this, k over 3 times 354, which is the total of this, is equal to 1. And a tiny bit of algebra gets us to the point where k is equal to 3 over 354. And we can, if we want to, simplify that to 1 over 118. However, you'll notice that here we have a denominator of 3. And so it's easier to leave the fraction in this form and simply eliminate the 3's. So we wind up with this as our probability function, if you will. Okay, so we found k. We know that we are now dealing with this, and so our next job is to find what we actually came here to look for. So let's go looking for the mean. Now the mean is simply the expected value of the outcomes given the probabilities. So what do we do? Well, in each case we have to figure out what 0, 1, 2, 3, and 4 to the power of 5 is equal to. Now, why that? Because if you look at our formula here, the expected value of x is equal to the sum of x times those probabilities. We have an extra x in here. And so when we write this out, we get this equation here, which we can simplify to this. And remember, we've figured out what k was equal to, and we can rearrange this so that we've got 1 over 354 times the sum of the values of x to the 5 from 0 to 4. And as I showed earlier, we have these values here. So the sum total of this is 1300. Right. So what does that give us? Well, it gives us the expected value of x as being 1300 over 354, which simplifies to 650 over 177. Simple bit of simplification of fractions. We'll use this later. We can write this as 3.67 to 2 decimal places, and while that's handy, we are actually going to use this later on to get an exact, or as close to an exact value as we can for the standard deviation. So we have the mean. Now, in order to find the standard deviation, we need to have a quick look at the formula for the variance, because the standard deviation is the square root of the variance, and we need to calculate this, the expected value of x squared, as opposed to the expected value of x all squared. Now this is each part of this squared. Right. So let's go. Let's do that. And here we are. So the expected value of x squared. Now we're squaring x, so we're jumping up another power from 5 to 6. Remember, we started at 4. So it's 1 over 354 times the sum of the values of x to the power of 6 between 0 and 4. Here they all are. You can see them. I won't call them out. They total to 4,890. So if we figure out the expected value of x from this, it is 4,890 over 354, which is 815 over 59. Again, just simplification. And for ease of reference, it's 13.81 to 2 decimal places. Okay, so where do we go from here? Well, the risk is that we use this number and this number to go ahead and calculate the variance. There's a lot of rounding that's gone on, and I did this on a calculator, and I found that I was 0.03, I was 0.03 out from the value I got when I just used fractions. That's quite a difference. So just be careful. These are handy references, but you keep your rounding right till the end of a problem. Okay, so let's have a look at the variance and therefore the standard deviation. Now, the variance we find using this formula, which I showed you earlier, and what we're going to do is we're simply going to substitute in the values. So 815 over 59 minus 650 over 177 all squared. Now, remember, I got this and then I converted it to a decimal just for a reference, but when I'm doing this calculation, I'm using this. And when I do that, I get this lovely long decimal. I didn't bother working it out as a fraction. I could have, but I didn't have all day. So this is the variance. Now the standard deviation is the square root of the variance, and therefore we simply take the square root of this number and we get this, which I have then rounded to 2 decimal places, 0.057. And as I mentioned earlier, when I did this on a calculator just using the 2 decimal place numbers, I got 0.6, which is quite a way off 0.57. Anyway, I hope you found this useful and interesting. If you did, please like and subscribe, and I will see you next time. Bye.